we're still going to look at the nature of the roots. But here is a little bit different way of questioning. So let's go and have a look and see what it means. For which value or values of k will 4x squared plus 3x plus k equals 0 have unequal roots? So they tell us we want unequal roots, and when we look at this quadratic equation, we can see that it's not complete because we do not have a numerical value for k. So we want to know what must this value be so that when we calculate x by using this quadratic equation, and obviously this k is now a numerical value, then we will get unequal roots. So let's go and see what we can do. We simply write down our quadratic equation, 4x squared plus 3x plus k equals 0, and then we make sure that it's in the right order. So all our terms on one side, and then it must be in the form of ax squared plus bx plus c, where the 4 is the a, the 3 is the b, so here we have bx, and the k will be our c. Now we can simply calculate our discriminant with b squared minus 4ac. So in the place of this b, we're going to put the plus 3. There we go. Then we have the minus 4, there it is. And in the place of a, we're going to put this 4, there it is. And in the place of c, well, that is now our k. So we're going to put k in there. And then this value is 9, and minus 4 times k is minus 16k. Now, as you can see, this is not just one value. So we cannot use our work that we memorized yet. So what we're going to do is we're going to use this clue of unequal roots. Now, when we have unequal roots, we simply write down that unequal roots is when delta is bigger than 0. Now, at this point, delta is 9 minus 16k. So we simply say 9 minus 16k is bigger than 0. And then we move this constant to the other side. So we have minus 16k is greater than minus 9. And then we're going to divide with this minus 16, which is the coefficient of k. And when we divide with a negative coefficient, this sign is going to swap around. So then we have k is less than 9 over 16. So now we have that k is less than 9 over 16, and that answers this following question. Because when k is any value less than 9 over 16, and then we work out x, we will see that it will have unequal roots. And that is all there is to it. Let's go and look at one more example. Now here is another example, and pay close attention because there's a couple of things that we need to change. So for which value or values of k will x squared minus kx plus 1 equals minus 2x have equal roots? So what value must this k or values must this k be so that these x answers will be the same? So what we're going to do is I'm simply going to take this quadratic equation. I'm going to move all my terms to one side and write it down. So here we go. X squared minus kx plus 2x plus 1 is equal to 0. And as you can see, this is a quadratic equation with all my terms on one side. But there's just one significant problem here. This is not in the right form yet, because remember, we want ax squared plus bx, but look now, there's another bx plus c, and usually it should just be ax squared plus bx plus c, and here we have a bx and a bx, so we need to take both of these and change it into one bx, one term. Okay, so I'm going to look at these two terms, and then I'm going to take out a common x. Actually, I'm going to take out a negative x. So here we have x squared, and then I take out a minus x, and then minus kx divided by minus x is just k, and then plus 2x divided by minus x is a minus 2. So there I did the common factor, and don't forget about this plus 1, there it is. And now our quadratic equation is in the right form. Ax squared, and this is our bx plus c. And to show you more clearly, I am going to just rewrite this in a better form. I'm going to say x squared minus k minus 2 in brackets and put the x plus 1. And now you can easily see that this is ax squared and this is our b and this is our x. So this is our bx and the plus 1 is our c. Now, because we want equal roots, we want to quickly calculate the discriminant delta, which we do with b squared minus 4ac. Let's do some substitution. In the place of b, we're going to put the minus k minus 2 in brackets. And there it is. And don't forget about the square. And then we have minus 4. In the place of a, we're going to put this 1. There it is. In the place of c, we're going to put this 1. And there it is. So this is a product of two binomials. The minus squared gives us a positive, so I don't worry about it. And then this bracket will be simply k times k is k squared. First times the second times a 2 gives us minus 4k. And the second times second is a plus 4. And then when we calculate this, minus 4 times 1 is a minus 4. And then we simplify this and we end up with k squared minus 4k. And then I can simply factorize this again. So I take out a common k and we have k and in brackets k minus 4. There we go. So because we want equal roots, we know that delta should be equal to 0. And delta is k in brackets k minus 4. So k in brackets k minus 4 is equal to 0. This is a zero product rule, which means that what makes this k a 0 when this k is a 0? And then what makes this bracket a 0 when k is equal to 4? And that is our two answers for k. So when this k is a 0 or a 4, and then we work out the x for this equation, you will see that they will have exactly the same answer. Therefore, they will have equal roots. And there we go. Hope you could follow. Good luck with the examples. And see you next time.